Alrighty, fantastic. Folks, welcome to week three, day one of Golf Evening and Weekend Platoon. Today, we're going to be talking about two useful, interesting, and somewhat strange function or part techniques for functional programming. These are known as currying and decorators. So currying is unfortunately not the method of making a stew, though I wish it was, but it's a way to help customize your functions. And more specifically to create customizable functions. So, for example, let's say that we would like to create a function that makes a number a specific length. So, for example, let's say that you are working at your client is a university, and the university has a system of they want to create new ID cards for all of their employees. And instead of having, before, let's say this university had like 20 people, so their ID cards before were like 1, 2, 3, 4, 5, blah, 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 18, 19, 20. But now the university has magically grown from 20 people to like 20,000 people. So now their IDs numbers go from 1, 2, 3, 4, dot, 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 to like 99997, 99998, 99999, etc. Now, if you're printing out ID cards, having some numbers be 1 digit long and some be 5 digits long looks a little bit weird. How can we fix that issue? The answer is adding zeros. So if we added, let's say, if we made all of these numbers have the same number of digits, we had those all be zeros, these all be zeros, those all be zeros, and then we removed the commas, all of the ID numbers are now in the same standard format. But we need a function that lets us do this. So let's design a function to do that. So we can call this function pad, hypothetically, and we're just gonna give it a return, like a notional return. And let's start figuring out how we want to pseudocode this. So anyone have ideas? Where can we start? So what should the inputs to this function be? And what kind of things should this function do in order to turn, say, a 1 into 1 with 4 zeros at the end, at the start? Anyone got an idea?
Well, at some point, you'd have to see what the longest number is, turn it into a string and get a length, I suppose, so you can match it, unless there's an easier way to do that.
So that could work. Here's an even easier answer. What if, well, we also need to define the inputs, right? So we're going to have inputs, out, outputs, and then pseudocode. So what if the university actually told us how many digits they wanted to make all of their ID number? Or let's say that the university gives us two inputs. It gives us the original ID number, and then they also give us the number of digits they want the ID number to be. And then our output would be new ID number equals old ID number plus requisite number of zeros. So we have, we can write a quick little example for ourselves. So let's say that the first ID number is, I'm going to keyboard mash. That's a terrible keyboard mash. There we go. 927. Somebody pick a number from 1 to 10 that's ideally not too long. Okay, I think I heard 5. So let's say that the university has given us an ID that's 927, but they want to make it 5 digits long. So how can we do that? Well, we do 927 and then we add 2 zeros, and that's our ID number. So that's about what we need to do. Now, let's start thinking about how we can pseudocode this. So first, we should probably create some variables. So let's say that we want to say that we can just call this one like um, ID original is the original ID number. And then we can say num digits. And then we can say ID, let's call it padded, is going to be the new ID number. So based on these two inputs, how can we generate the end or the end result? So
To
I
count
think
the number of digits.
perfect. Yep. So I think the first thing we should do is count the number of digits in ID original. What could we do next?
If it is less than 5, get what that difference is and add that many or insert that many zeros at the beginning.
Okay, so if the number of digits is less than, all right, in ID original, this is a really long phrase. I don't want to keep saying that. Let's create a variable for it. Why don't we say num digits ID? And then we can change that to say if num digits ID is less than num digits, then we would, let's see, sorry, what was the
Get
second part again?
get the difference
Okay, take difference of the two.
and then take that difference and put that many zeros at the beginning of the what's the number called? The num digits or not the num digits, the I'm getting confused. Which one is it? The
To
short
the
number.
start of the ID,
Yes.
to the beginning of ID original. Okay. And then I guess we should also probably
Return.
say that this is going to be ID padded. And then I guess we can just return that. Now, now here comes the fun part. What happens if the ID is longer than the number of digits required or equal to, or if this statement is false?
If it's equal to 5 digits, then nothing needs to be done, right? It just needs to return that number.
Make an edge case for that.
Yep. So this is going to be our edge case. So we have edge case, num digits ID is equal to num digits. And then we're just going to return ID original. We have one more edge case, which is if the number of digits requested is larger, or sorry, if the original number is larger than the number of digits required. So like if I give you, say, let's say I change this to 2. Well, this makes no sense because 927 is 3 digits long. And you want me to make it 2 digits long by adding zeros? I can't do that. So for that, we have a couple of options, but I'm just going to go with the simplest one for now, which is we are going to print an error and just say, or we're going to make a print statement that says there is an error. We just say error, number of digits requested is longer than ID number. And then we are just going to return like nothing or return a blank string.
So I have a question, and this is a little bit out of the scope of things, so I'm sorry. But so
Go for it.
if this is your edge cases are going to be based on how the data is actually entered into wherever you're pulling it from, correct? So if it's an input based, you're going to limit the input. If it's a database thing, you're going to probably check the format of the numbers, correct? So if there's
Correct.
like 3 zeros, you could drop zeros and bring that number in or something like that. Like
Yeah,
three
I mean
leading zeros,
hypothetically.
etc. Okay.
Yeah. but your edge cases are almost always going to be related to something from the input in general. There are some cases where that won't happen, but for now, you can assume that. So also, one other thing is also probably important. Um, let's assume that we are going to take in the original ID number. Let's say that we're going to take it in as an integer. They're giving it to us as an integer, not a string, not a float, an integer. Now, the output, and this is also going to be, number of digits is also going to be an integer because I don't want to, it just makes it easy. Now, for padded, which is the new ID number, which is the old number plus a bunch of zeros at the start. Do you guys think that is still going to be an integer? Or might that need to be another type of variable?
If you're trying to output it, it'd have to be a float, right? If you're trying to output a digit type of type.
We can output integers as well, but the main thing that I want you guys to take a look at is in the output. Remember that we're adding in leading zeros.
Isn't there a way? I can't remember the exact name. Is it octal? It isn't hex because there's hex, octal. Since we you can convert it. But I don't remember what it's
No, you're
called.
right. We could do that, but in this case, we don't want to convert it. We want to keep it all base 10. That is a
Oh,
good point, though.
Would we have to convert it to a string to get the zeros?
Why would we need to convert it to a string to get the zeros?
I don't know how else to get the zeros in the beginning.
Okay, so here, let's try it. So let's make a print statement, right? So our original number is going to be like 927, which is an integer. So hypothetically, if we could just return it as a regular integer, we can return 00927, right? And it's what it should, which is what we're saying. We're adding zeros to the start. If I run this, we get an error. And it says leading zeros in decimal integer literals are not permitted. So unfortunately, we cannot keep our ID number an integer. We have to change it to something. Now, as Mike correctly noted, we could change it to octal to add that zero, or we can turn that into a string. And if I turn that into a string, and we hit run, we start with an integer, and we change it to a string. And with the string, zero doesn't mean anything. Zero is a character. I can change the zero to an exclamation mark or a comma or any other string or any other character, and it doesn't make a difference. So we can add the zeros, but we have to turn this integer into a string. So let's add that to our pseudocode. So we need to turn ID original into a string to the beginning of the ID original string as a string. All right. So I think we've got most of the code written out. Now, let's start actually, coding this. So I'm going to, let's see if I can split this. So I'm going to have the pseudocode open on one side and the part where I want to code down here. So hopefully that's not confusing to anyone. If it is, let me know. But this is usually what I like to do is I'll either have my pseudocode in a separate document or a separate window. So that way I can look at my pseudocode at the same time as I'm typing the code. So let's see, what did we say the inputs were? So we said the inputs to our function were ID original and then num digits. So the first thing that we need to do is turn the original ID into a string. How can I turn an integer into a string?
Well, do we want to do that in the beginning? Because then if they enter instead of a number, a string, that would cause issues. Wouldn't we want to turn it into a string after we get, or like getting the zeros in the front.
So let's assume that they always enter it as an integer.
Okay.
str wrap the integer.
Perfect. So let's call this ID string is going to be str ID original. So now we've turned that into a string. Now we need to create a new variable called numDigits ID, and we need to count the number of digits in the ID. Given that we just turned it into a string, how can we check the number of digits in that original ID?
The length, len, with it in parentheses.
All right, so we can check the length of the ID string. And then now we can do our if statement. We have if numDigits ID is less than numDigits. That's pretty simple. And then we can, do stuff in there. Well, actually, here, let's write that out now. So we can take the difference of the two. So we have numDigits needed is going to be numDigits minus numDigits ID. And then ID padded. So we need to add zeros to the start of the string. How can I do that? How can I add zeros?
Insert.
We could use insert, but insert would only add 1 0 at a time.
Now, do we already know the number of the zeros that we need to add? Because if we do, then we could just concatenate it.
Yep, we could concatenate it, but how do we come up with, so we have the number of zeros. What we don't know is how to turn that number of zeros into an actual string with those zeros. So that
Okay.
is the problem that I pose to you all right now. How do we
Can't you,
turn the number of zeros into a string with those zeros?
can't you make a variable? I'm not sure where, but make a variable that basically says like number of zeros equals string zero times the number you need. So times one would be one, times two would be two zeros. So it would equal a string of two zeros.
Perfect. Yep, that's what I was looking for. So we can say zeros needed, or zeros for padding, is 0, the string, times the number of digits needed. So if the number of digits needed is 1, you have 1 0. If it's 2, 2 zeros. 3, da 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 da, etc. And then lastly, we have that ID padded, which is where we're going to concatenate our strings. So we're going to say that this is zeros plus the ID string. And then we're going to return ID padded. Now, I'm going to make a small change here. We have our edge case. We say the number of digits in the ID is equal to the number of digits. So what we can do now is we could say else if num digits ID is equal to the number of digits, and we'll put a colon. Oh, there we go. Elif is what I was looking for. So we can just return the ID as a string, which is a variable we already made before. And then we can have our else statement, and we'll just do that little print and return nothing. All right, so here, let's make it all bigger again. And here is our slightly complicated function.
When those edge
But
cases need to come first. So it kind of
yeah,
like rules them out before we start building out our zeros.
that is probably a good idea. So let's flip it around. So let's say if, all right, so let's copy this, and we'll put that in here, and then we'll put these in there. Then we'll say else or elif, and then, oh, we can just actually copy that. And then now we have an else, and we don't need that because that's a guaranteed condition. Okay, I think that's a little bit better. Thank you for that catch, Sean. So what do we think about this piece of code? Does that look like it makes sense? Does anyone have
Uh,
any questions about how we got to this point yet?
I still don't understand the zeros for padding. It's call there.
Okay, so in Python, if you multiply a string by a number, it will duplicate that string a specific number of times. So if I say, let's say the string A, and I multiply it by 5, and I hit run, it will create 5 A's. Similar vein, if I make it a longer string, it will duplicate that string the requisite number of times that you multiply it by. So what we're
Okay,
doing with zeros for
got it.
padding, yeah, with zeros for padding, what we're doing is we're multiplying 0 by the number of digits needed to duplicate it that many number of times. And then we're adding that to the start. So let's check that this works. So somebody, let's give me a number between 1 and 10.
3.
Okay. So, and somebody give me a number between 6 and 10.
8.
8. All right. So we need to make the ID of 381 8 digits long. So if I hit run on this, we should get 381 all the way at the end. And 8 minus, so this is 1, 2, 3 digits. 8 minus 3 is 5. We should have 5 zeros. Now let's see if that actually works. Okay, it did not, and here's why. I flipped around the ID, original, and the number of digits. So it now thought that the ID was 8 and the number of digits was 381, which explains why it printed out so many zeros. So maybe let's flip that around and let's change it to an 8 in there. There we go. That looks a little bit more reasonable. So let's count how many digits we have total. 1, 2, 3, 4, 5, 6, 7, 8, and the 381's at the end. So it looks like our code worked. So first test case of doing what we expect looks like that's checked out. Let's move on to our edge cases. Now let's first check if the number of digits that's requested is equal to the number of digits in the number, and it returns the original number, which is good. And let's say that we only want this to be 1 digit long. It should give us that print error and return nothing. And we get that error, and it returns a blank string. Now, this is a very rapid case of testing our function. Normally, I would encourage you to try more numbers, try more cases, but for purposes of moving forward with the lecture right now, I think this is probably adequate. So, are there any questions about the function that we've designed so far, or anything about that before we keep moving?
I have a quick question, and if we need to come back to it, that's fine. Is there kind of like a general template or methodology used to create test cases, such as like start here and then look down the line, or are we just doing it very much so based on the current function, and then from there the whole module, etc.?
So I generally will design my tests in two ways. The first one is I'm going to look at the inputs and outputs and say, what are some input exceptions to inputs that my user might put in that I need to keep in mind? Or what are some weird outputs I might get that I need to double check? Then I'll look at my pseudocode and I'll say, where could things go wrong in the pseudocode? And that's where those edge cases come in or your error cases and add that to my list. Then I'll go in and look at my actual code and I'll say, all right, where is something in here that could go critically wrong? So it's sort of, you start from a high level of, here are my requirements. What are weird things in my requirements that could throw an error? Then here's my framework. Where are things in my framework that could throw an error? And then here's my actual code. Where could things go wrong here? probably what I would recommend at this stage for everyone to think about is sort of those three levels and those three steps. Does that help a little bit? Okay, awesome. Any other questions about this function or about the testing or the pseudocode or any of that before we move on to the actual material of today? All right. So we've designed this function called pad, right? That now has you've got your original ID and you've got your number of digits. Um, just for formatting, I'm gonna flip these around like I originally had it. So we'll say 8, and then we'll just button mash that. So now the number of digits is the first thing, and the ID that we want is the second thing. So let's assume that our function almost always uses, or that the university almost always uses 8 digits in their ID. There's a couple of different ways we can go about that. Now, the first thing we can do, which is a neat little trick, is you can set the default value of a field in Python of a function. And you can do that by setting it, oh, well, we'd have to flip it back. Okay, let's do that real quick. So flip that back one more time. The first way that you can set a default value for a field is if it's at the end of the function, at the end of the arguments list, you can set it directly equal to something. So what does this mean? This means two things. I can run pad and specify the ID and a custom, um, you know, length for a number of digits, and it'll still work the same. But if I run pad with specifying what the number of digits is, pad will assume that because I didn't specify it, I want the number of digits to be 8. So that's what setting a default value does. It says, hey, if you don't tell me what the number of digits is, I'm going to assume that it's 8. On the other hand, if you tell me, then I'll assume that it's whatever you just typed. That's the first way that you can circumvent that special rule, quote unquote, of sorts. Now, there's another way, which is the way that I'm actually supposed to teach you guys to do this today. And to do that, I'm going to create another function, and we'll call this pad curried. So this is where currying comes in, where you are sort of nesting functions within functions. So what we can do is, let's say that, well, we're now going to create a brand new function inside of our pad curried function. And we're going to call that new function, let's say inner courier. That's probably not a word, but that's okay. And we'll do that. We'll do this, and then we'll go back one, and then we'll say return inner courier. Okay, so I just did something very slightly weird, and I'm going to make my terminal a little smaller, so that way you can see it. What I've just done is I've nested a function, which is this inner courier function, within my pad curried function. What is the benefit of doing this? The benefit of doing this is I can now create custom functions that are variations of my original pad function. So let's say that, so the use case for currying versus that thing that I did before, where we flipped it and said, and had the default value for number of digits as set as 8. And here, let's just flip this back. We'll say 2, 4, 1, 5, and then like 10. Setting the default value is extremely useful. If you only have one special case, right? So here we're assuming we have two cases by doing it this way. Either the number of digits is unspecified, in which case num digits is 8, or num digits is some custom thing or custom number. So you have two cases here. By using currying, we can actually improve this process even more. So let's say that you are now working for two universities. We have client A has an ID of length 8, and then client B has an ID of length 12. So if we were to do, write this function and we want this function to be usable by both clients, well, you have two options. Number one, you can forget specifying, because remember, default values only let you specify one default, not two. So either you forget the default value, and whenever they type their ID, you make them pad it by specifying 12 and 12 and 12 and 8 and 8, which looks ugly. The other option is you can prioritize one client over the other by making them the chosen specified default value and make your other client feel really bad about themselves because they were not chosen to be the default value. Both of those are not great options. So we have a third. And the third option is to curry and you give them two different functions. So for client A, whose ID is of length 8, what we can do is we can define a new function that's a version of this curried function. So we can say ID client A is equal to pad curried, and the input is going to be the number of digits they want, which is 8 digits. And we can do the exact same thing for client B and change it to 12. So now, whenever client A wants to make an ID, all they need to do is run their custom function for client A that now they can put in their ID. And the same thing for client B. So we can say ID client B, and then they can put in, their number. Now, here, let me comment this out very quickly and make sure we don't have any other print statements. So let's make sure that what I'm doing actually works, and then we'll talk a little bit about why. So as we see here, if I'm running ID client A is pad curried 8. So that means that I am running pad curried, but I'm setting the number of digits to always be 8. So whenever I run ID client A with 8963, this is the equivalent of running my pad function and specifying, what was that, 8963, and then specifying that the number of digits equals 8. Similarly, if I'm doing it for client B, we're doing the exact same thing. However, here we're saying that ID client B is the same thing as running that pad function we wrote, but we're specifying that the number of digits is 12. That is all that currying does. If you have a case where you need to develop multiple special versions of a function, it's not a bad idea to create a inner function that actually does all of the essential things it needs to do, and then specify the argument that makes it special in a outer nested function, which is exactly what we did with pad curried versus pad. Does that explanation make sense? Are there any questions about what we just did with currying?
So, in a nutshell, it's just copying the original function and making it unique for the special case, or it's nesting a function in the inside of it for whatever the special case may be. Is
Pretty
it's
much.
okay.
Yeah. So it lets you make as many special cases as you want. And again, we can already do that here at the original function that we had by just continuously specifying the number of digits. However, this just looks ugly. This looks a lot nicer. You have, one piece of parentheses, just one argument, a simple description of the function. This just looks ungainly. So this is the reason this is a functional programming method is this guy and this guy do the exact same thing, but this just looks better than that. And it's a little bit, again, more effective in terms of when you're going through the code, seeing, okay, this is a special case, this is a special case, this is a special case, and so on. Other questions about currying?
I have a question. So one of the things that comes to mind as I was looking at this, um, developing an inner function, I can see the benefit of it, but what would be like, I also started to think about a switch statement, right? I mean, I already know that Python doesn't have a switch. Well, no, now they do, I think, in the later version. But I remember before it didn't have a switch case statement. So is there also in the possibility of instead of having to nest a function, you just nest the cases instead?
You could, but that would get really long.
Okay.
So, because then what you're suggesting is copy pasting this for each of the cases in your switch statement and just changing the number of digits to be, each of the cases. That would be a little bit too much, if that makes sense.
But isn't the currying doing the same thing? Because if you're having to add different functions for unique cases, or is it just if you have to do currying, it's a limit of just nesting it to one function, or no?
Yeah. Yes. So, well, let me rephrase. When you're currying with a function, you generate the ability to create as many functions or sub functions from it as you want. So we generated that pad carried function up here. We can specify as many special cases of that function as we want to without having to rewrite the whole function every time and specifying it in there. That's the main benefit of currying.
So when you say specify the function, will you go back up in your code? Okay, so here, if we call pad curry, or then wait, so where are you calling? Okay, so you are returning inner curry. So if you add another function in there and you nest it, so if you have two or three separate nested functions, wouldn't you have to duplicate that code again, or no?
Nope.
Why? I don't. That's what I'm missing. So because you have a nested function in a curry, so if you're going to nest something else, why would you not have to write code for it?
So let me back up a little bit. By nesting the function within the function,
Mhm.
we aren't removing we aren't exactly creating a independent new function. All that we're doing by splitting it up in this way is again this function and the function we did above are identical in terms of, I hate to use the word, functionality. Like they both do the same thing. The only difference is by using this method where we're wrapping a interior function in an outer function. The only thing we're doing here is we're making it easier to generalize the use case. So
Okay.
here, yeah. So again, going back down to this example, right? If I have these two use cases, for now, it could be more. It could be 3 or 4 or 5 or however many later down the line. Originally, what I would have to do, here, let me delete this and make it a little bit more obvious. What I would have to do is for each of those individual use cases, I would have to run my old function and then specify inside it every single time the number of digits that I wanted. So, let's say I would have to, do this for, this other ID and then do that for this guy and then, this. Like, it doesn't look good to do that. And also, because if you're looking at these, which all have 8 digits, and then, let's copy paste this here, and we'll change these all to 12, and let's just change the numbers. If I ask you to look at these 4 lines of code and these 4 lines of code, which are for two completely different applications, two completely different purposes, you will say, rightfully so, that they look almost the same, except if you're glancing at it really quickly, the number of digits is different, but that doesn't signify anything. In contrast, with this curried method, we can define different functions that are versions of that inner courier, where we're now specifying the number of digits. So for now, if we were to do this exact same thing, oh, that was, no, copy. And here, I'll just type some other IDs in. Now, if I look at the code, this tells me immediately, okay, I'm doing the whatever client A wants, which is I'm padding with 8 digits, and I'm doing that repeatedly for all of these. Being able to look at your code quickly and see what it's doing is the main benefit of currying for something complicated like that. That was a little bit of a long-winded explanation, but Mike, does that help a little bit? And anyone else who's having trouble as well?
I understand what it's what you're doing for the usage case. I can see it the way because you got the outer function and then you have a local function that's just for that curry. So I understand what's going on.
Okay, awesome. Does anyone else have questions about that? Alrighty. If not, let's move on to the second topic of tonight. Here, I'm going to comment out all of this stuff for a little bit. Let's move on to the second topic of tonight, which is decorators. So while currying is a way to create functions that run multiple times, that you can generalize, decorators are used if you want to sort of do the opposite. It's if you want to modify multiple other functions. So let's say that you want to, run your pad curried function, and then I want to generate a confirmation message at the end. So let's say, fine, generate new IDs, and then we'll say like ID number, and then and let's say that this is going to be generate 8-digit ID. So what we can do there is we can say that ID 8-digit is going to be pad curried of 8, and then we're going to say new ID is going to be 8-digit ID generator, and we're just going to input the ID number into it. Then we're going to, let's say we're going to print ID generated, and then we are going to return new ID. So this will, whatever number we input, it's going to generate your 8-digit ID and move along. So identity fraud is a problem. We don't want to create multiple IDs for the same individual. Like, let's say that, this generate 8-digit ID, then as soon as you hit return, it'll print out the ID on a printer or something. If one person had ended up somehow having like 5 identical IDs, that could be a bit of a risk. So what we would want to do is figure out how to, I guess, limit the number of times that you generate this ID. And for that, we can use a decorator. So what a decorator, the format of a decorator is a little bit weird, and it's honestly stranger than for currying. So I'm going to try to explain it in relatively easy to understand terms, but if anything isn't clear, let me know. So let's say that we only want to generate an ID one time per ID per user. Only run the function once. So let's create a way to do that. So let's define a function. We're calling once, and we're going to, return something. We don't know what yet. But this function that we run is going to be our decorator that we are only running, we're only letting it run one time. So how can we do this? Well, presumably, what we need to do is figure out how to track. So this decorator only allows function to be called once. So first we need a way to track if it's been called. So has the function been called yet? Function been called yet? So if it has not been called yet, then call it. If it has been called, then don't call it again. Throw an error or throw an exception, which basically says, hey, you can only call this function once. Don't do this again. So let's figure out how we can track that. So the first thing that we need to do is set up a variable, and we're going to call it called, and we're going to set called equal to false, right? Because the first time that you set up a variable, that you run a function, it should automatically evaluate to it hasn't been run yet, so your variable should be false. Now, the next part is where I'm going to start bringing in some syntax. And again, please ask questions about this because it is weird. The first thing we're going to do is just like with the currying, we're going to define an internal function. And we're going to call this function inner. Now, with currying, we are specifying a condition to be specified and then the other inputs that are known to the function. In contrast, for decorators, because we want decorators to be applicable to any function, the inputs to the inner function in your decorator are going to be just overall arguments, which is basically all of the arguments to your original function. So we're defining that. And the first thing we want to do is check if the function has been called or not. So we're going to use this non-local feature and specify called. And that essentially what saying non-local lets us do is it specifies, hey, when I run f, that function that we input, with these arguments, called is now going to flip to true because it's been run non-locally. So now we can do our little checks. So, oop, has the function been called yet? We can check that using an if. We can say if called, and then here it says, let's see, if it has not been called. So we can just say if not called. And then if it hasn't been called, then we can say that called is now true. So we will call it. And then we're going to run our function f with whatever arguments are specified by, by the user. And then we need to actually return the function. Because if we don't return the function, then nothing actually gets returned. Oh, Sean, just saw your question. Does the star before args do anything specific? Yes. The star before args essentially says that all of the arguments to f, where f is your original function, get passed in to this inner function. So if my function f originally has two arguments, like up here, then the star args will pass forward all of the arguments that you put in. If my function has 15 arguments, then likewise, it will put forward all 15 arguments when I'm running f. If you don't do that, speaking broadly, you're going to have to input, like hand type every single argument that you want passed in, which we don't want to do. So for decorators in general, you want to use the star args because that lets you say all of the arguments of my function are all going to get passed in.
What is that non-local?
So the non-local basically refers to called, which is not a local variable, as in it's not local to the definition of the function inner. You don't see non-local used very much, except honestly for decorators. And that's because we want to tell Python that called equals false is something that is only specified within the next level up. So it's not a global variable. It's not defined everywhere in the code, but it's also not just defined within this function inner. It is a special non-local variable that needs to be reevaluated in the context of the once decorator.
So non-local, I will read about it, but basically it just looks on the outside of the parent function. Well, I mean, in this case, the inner is the child, but when I'm saying non-local, referring to the parent would be inner, but it's going to look on the outside for that variable.
Yes. So non-local, I also just double checked this, and I'll send the link after lecture is done. But non-local is only used in Python for nested functions, which is basically decorators and currying, but mostly decorators. So what non-local does is it says, hey, look up at the variable called, pull that variable from the parent function. That's all it does. All right. So if
Thank
there are
you.
other, yeah, no problem. If there's other question about that, let me know. Otherwise, I'm going to fill out the remaining one piece of this, which is the throw an exception. So an exception is not an error. And here, let's see. It doesn't tell you what an exception is. Okay. Well, I was hoping it would. So an exception is it'll basically tell you, hey, you're doing something that you are not supposed to. It's not saying error, your code is broken completely, but it just says it's a way to sort of draw attention to, hey, you're doing something you shouldn't be doing, so think twice about it, and it'll stop running your code. So here we can raise an exception that just says you can only call your function one time. And then we're going to just return inner. That should be good. So what is this decorator doing? So for a given function, we're checking if that function has been called. If it has not been called yet, then we won't let it get called again. And we're just going to return the function. We'll let it run, do whatever it needs to do. However, if the function has been called, then we can't call it again. So you're going to throw that exception and move on with life. So let's actually apply this decorator to our generate 8-digit ID. We only want to generate one ID. So what we can do is we can use an @ sign and type our decorator. Okay, here, let's move this after our decorator. So what this will do is the @ sign will apply the once decorator to our generate 8-digit ID function. So it'll only let that be run one time. So let's see if this actually works. So I'm going to type in an ID. We're going to hit run. And we see that it has printed out that it's generated our ID. So that's good. But let's say that I tell it to generate, let's say, more than one time. We see that it runs it the first time. It says ID generated. And then it raises that exception. And it says you can only call your function one time, which is exactly what we asked it to do. And again, how did we do that? We specified that local variable called, or that non-local variable called. And the first time we ran the function, it sets it to false. And then it flips it to true because we ran it once. Then, when it was true, we said that it's run once, so you can't run it again, so we raise that exception. And then again, by doing the @ sign before the decorator, before once, we were able to apply that decorator to our function. Decorators are confusing. Do you guys have any questions about them at this time?
If you put like a check for how many times it was running inside the decorator, I guess, could you make it run twice and then throw an error? Is that a thing?
I don't know. Let's see. How would we do that?
Like maybe put check equals 0 and then within the def inner, like it would increase it every time it runs. I don't know if that's possible, but
Let's try it. So let's forget about called for a second. And let's say if check is equal to 2. So this will let it run. Let's see. Wait, let me think. So 0, then it runs once. Or here, let's do if check is less than 2. Then we'll just say check plus equals 1. So the first time check is 0. So if check is less than 2, it is. So then it makes check 1, and the function runs one time. Now check is 1. So it's still less than 2, so it brings it up to 2 and lets it run a second time. And we go back here, check is now 2. 2 is not less than 2, so it should raise the exception, hypothetically speaking. Now let's see if that actually happens. Let's try it with running twice first. It does work when we run it twice. And let's try running it a third time. And we get the exception. So yeah, Sean, I think you're right on about that.
so essentially a decorator is preserving some I don't know how to say this, but like preserving some variables within in itself.
Yes. Or more specifically, this decorator is something that we applied to this function by allowing it to keep track of some thing inherent, somewhat inherent to the function in terms of like how many times it's run. Again, it is confusing. But does the overall concept of what a decorator is or what we did with this one decorator make sense to everyone so far? Are there any questions about currying, which is where we, again, nest functions, but we do that in order to create multiple functions that are specific instances of our original function, like with that client A and client B and creating functions for each of them. Whereas decorators is where we're applying a function to another function and changing its behavior. Does that distinction make sense? And are there any questions about either of those before we take a short break? Alrighty, so let's stop the recording